Hello, this is Miss Martinez, and I'm going over the ACP sample items 11 through 15. Question 11 says, which chemical formula is an example of an empirical formula? So this is where you have to remember the definitions of empirical and molecular. A molecular formula is a formula that can be simplified. An empirical formula is a formula that cannot be simplified. It already is the simplest ratio. So since we're looking for an empirical formula, we're looking for which one cannot be simplified. An easy way to identify whether you can simplify your formula is if all the subscripts are even numbers, that means you're going to be able to divide by 2. So look at answer choice A. We have H2O2, dihydrogen dioxide. You can divide 2 by 2, that's going to give you 1. Since it's the same number for both of them, that's going to give us HO as our simplified formula, which is the empirical formula. Since we were able to simplify it, that means answer choice A is an example of a molecular formula, so that's not correct. If you look at B, it's exactly the same, different elements, but same subscripts, N2O2. You can divide both of those numbers by 2. If you hear my cat, I'm so sorry. N2O2, that's going to give us NO, which means since we were able to simplify it, that's not our answer. If you look at C, you have C3H2. You can divide 2 by 2 and get 1, but if you try to divide 3 by 2, you're going to get 1.5. You can't have decimals as subscripts, so it's looking like we can't simplify that one, which means it might be our answer, but let's check D just to be sure. B2H6, 2 divided by 2 is going to give us 1, so that's just B. 6 divided by 2 is going to give us 3, so that's H3. That means that's the empirical formula. And our answer is C, because that answer choice cannot be simplified. Therefore, it is an empirical formula. For question number 12, you need to be able to balance a chemical equation. So the first thing you want to do is grab your piece of scratch paper, copy down the equation, and then separate your product from your reactant. So draw a line right underneath the arrow and start listing your elements. On the left, we have tin, chlorine, and iron. On the right, you should have the same exact elements, tin, chlorine, and iron. Once you have your elements listed, start counting. So on the left side, we have 1 atom of tin, 4 atoms of chlorine, and 1 atom of iron. If we go over to the right, we have 1 tin. We have 2 chlorines here, but we also have 3 over here, which means you're going to have to add them together. So that's going to give us 5 chlorines and then just 1 iron. So the first thing to notice here is that your tin is the same on both sides. You have 1 and 1. Iron is the same on both sides. You have 1 and 1. Your only problem here is chlorine. You've got 4 on the reactant side, and 5 on the product side. So you're going to have to change some of those numbers. Looking at the reactants, this 4, there's really nothing you can multiply by 4 to give us 5. So let's start by changing this number over here. Since it's easier for us to work with even numbers, let's change this to something else. So just put a 2 in front of it and go from there. Sometimes with balancing, you just have to do trial and error. Put one number, if it doesn't work, try something else. So if we put a 2 here, that's going to give us 2 atoms of iron. And 2 times 3 is 6. 6 atoms of chlorine. But we already had 2 over here, so that's going to give us 8 atoms of chlorine total. So then if we go back over here to the right, we can multiply 4 by 2 to get 8. So let's put a 2 right here. That's going to give us 2 atoms of tin and 8 atoms of chlorine. But now we have a problem because if we move back over to the right, we only have 1 tin. So in order to have 2, we're going to have to put a 2 here. But if we put a 2 there, that 2 is also going to affect chlorine, which means we're now going to have 4 atoms of chlorine plus the 6 we had over here, and that's going to give us 10. And if we go back to the left, there's nothing we can multiply by 8 to give us 10. So this really isn't going to work, especially if you try to finish it. That means you would need to put a 2 over here to get 2 irons. And if you have 2, 2, 2, 2, that's essentially the same thing as just having 1, 1, 1, 1, which means we really didn't do anything. So that's okay. We just have to start all over again. So we're going to list our elements: tin, chlorine, iron, tin, chlorine, iron. We have 1, 4, 1, 1, 5, 1. I still don't like this 3, so we're going to keep our 2 right there. So that's going to give us 2 irons and 6 chlorines plus 2, that's 6, 7, 8. However, the 2 we had here didn't really work. Sorry, you can't see where I'm pointing at. The 2 we had here didn't really work for us, so let's change that to a 3 instead. So that's going to give us 3 atoms of tin, and then 3 times the 2 is going to give us 6, plus the 6 we had over here gives us a total of 12. So now when we go back over to the left, we have 4 atoms of chlorine. I know that if I multiply 4 by 3, that's going to give me 12, which is what I want. So I'm going to put a 3 right here. That's also going to give me 3 atoms of tin, which is good because I have 3 atoms of tin over here. Now my only problem is iron. I have 2 on the right and 1 on the left. Since iron is by itself, all I have to do is put a 2 in front of it to give me 2. And now our equation is balanced. We have 3 tins on both sides, 12 chlorines on both sides, and 2 atoms of iron on both sides. When you're taking your ACP, I would advise you to leave the balancing equations until the very end because you are timed. You have 2 hours to answer 33 questions. Balancing is not necessarily hard, but it is time consuming. So if you do it at the very beginning, you might run out of time for other questions. So get through the easier questions first and then do these types of questions at the end. You should only see 1 or 2 balancing questions on your exam. So just leave them until the very end. Okay, question number 13. The table shows properties of the halogens. So immediately, you know you're looking at one specific group on the periodic table, the halogens. If you drew your little chart at the beginning of the ACP, like we told you to, then you'll know that your halogens are over here in group 7A. Fluorine is at the very top. And then iodine is going to be closer to the bottom. The question says, which statement explains the physical states of the halogens at room temperature? If you read your answer choices, all of the answer choices have to do with dispersion forces, which unfortunately we didn't cover in class, but that's okay because we can talk about that now. So if you take a look at my picture over here with my 2 atoms, these are both atoms of sodium. We know it's sodium because there's 11 electrons. And as you can see, all of the atoms of sodium have moved over to the left, to one side. Since electrons are negative and they're all hanging around the same side, that means this side of sodium is going to be slightly negative. which means the other side of sodium is going to be slightly positive. So if a different atom of sodium comes around, all of the electrons on this atom of sodium are going to be attracted to the positive end of this sodium because opposites attract. So they're all going to move over here to the left, meaning this side is slightly negative and this side is slightly positive. So dispersion forces refer to the dispersion or movement of electrons. So the more electrons there are in an atom, the more dispersion forces there are going to be. So if you go back to your periodic table, we know that as you go down your group, if you drew your frosty over here, your elements are getting bigger. They're getting bigger and they have more electrons. More electrons means more dispersion forces. So the answer to this question is A. Dispersion forces become stronger as the size of the particle increases. All right, question 14. A redox reaction is shown. Redox stands for reduction oxidation, so a reduction oxidation reaction. Which statements describe what happens to magnesium in the reaction? On your periodic table, magnesium is the second element in group 2, which means it's somewhere around there, meaning it's an alkali earth metal. Magnesium is a metal. We know that metals always lose electrons. Since electrons are negatively charged, when you lose an electron, you become positively charged, and we know that from the oxidation number up here, +2, magnesium loses 2 electrons and becomes positively charged. So if we look at our answer choices, we have magnesium gains electrons, magnesium loses electrons, and magnesium retains its electrons. We know A and C can't be true, so we can pick B as one of our answer choices. It does say select 2 correct answer choices. Now we need to decide whether magnesium is oxidized or magnesium is reduced. So for this, you're going to want to remember our friend Leo the lion. Leo the lion says grr. So Leo stands for losing electrons is oxidation, gaining electrons is reduction. Since we know magnesium is a metal and it loses electrons, that means we're going to use Leo. Losing electrons is oxidation, which means our second correct answer is D. Last question, question number 15. You have an electromagnetic spectrum shown. So you don't need to have the types of waves or radiation memorized. You just need to know how to read a spectrum when it's given to you. So you can see that over on the left, we have radio waves, and the wavelength is pretty long. Whenever you have a long wave, that means you're going to have low energy and low frequency. And if you look over to the right, over to the gamma rays, you have really short waves. I can't even draw a line that short. You have really short waves, which means you have really high energy and high frequency. So the question says, which type of electromagnetic waves have the greatest energy? The greatest energy are going to be your shortest waves, which are going to be over on the right, which means our answer is A, gamma rays.